Good afternoon, students. Okay. Good afternoon. So in the morning session, we discussed about the LC oscillation and we derived the equation for calculating the frequency of LC oscillation. Achyut, what is the frequency of LC oscillation? Equation for calculating the frequency of LC oscillation.
1 by 2 pi root LC.
F is equal to 1 by 2 pi into root of LC, where F is the frequency, L is the inductance of a inductor, and C is the capacitance of a capacitor. So now we are going to discuss the next topic, transformer. All of you write the next heading, transformer. Transformers. So here you have the definition for transformer. A transformer is a device that changes voltage from one value to another. A transformer is a device that is used to change the value of voltage from one value to another. A transformer is a device that changes voltage from one value to another. That means it is used to either increase or decrease the value of voltage. Transformer is a device that is used to either increase or decrease the value of voltage, or it is a device that is used to change the value of voltage from one value to another. And a transformer possesses two ends, an input end and an output end. The power at the input end is equal to the power generated at the output end. Transformer consists of two ends, an input end. Input end means the end at which the energy is given, and an output end. The end from which the energy is taken out is known as output end. So in a transformer, the power that is generated in the input end will be equal to power generated in the output end. So with the help of a transformer, we can increase only the value of voltage. We can either increase or decrease the value of voltage.
Ma'am,
Yes?
is this transformer same as the one we see on the roads?
Ah, yes. Transformer is a device that is used to change the value of voltage from one value to another, or it is a device that is used to either increase or decrease the value of voltage. In the input end will be equal to that of the power that is taken out from the output end. In a transformer, the value of the voltage will either increase or decrease. Is it over? Okay. So here we consider this transformer. It consists of an inner iron laminated core. It consists of an inner iron or soft iron. It consists of an inner soft iron laminated core consists of a soft iron laminated core and two coils. And two coils. It consists of a soft iron laminated core and two coils, such that they are primary coil and secondary coil. They are primary coil and secondary coil. A transformer consists of a soft iron laminated core and two coil. They are primary coil and secondary coil. Primary coil is the coil. Primary coil is the coil in which we give the energy. Primary coil is the coil in which we give the energy. The coil at which we give the energy is called primary coil. And secondary coil is the coil from which the energy is taken out. Secondary coil is the coil from which the energy is taken out. It consists of a soft iron laminated core and two coils. They are primary coil and secondary coil. Primary coil is the coil in which we give the energy. The energy given coil is known as primary coil. And the coil from which the energy is taken out, it is driven out, are called secondary coil. Primary coil is the coil in which we give the energy, and secondary coil is the coil from which we take the energy out. Now we are going to describe some terms associated with the transformer. The number of turns of primary coil is represented by number of turns of primary coil is represented by NP. Corresponding voltage is represented by VP. And the current generated in the primary coil is taken as IP. So all these three terms associated with the primary coil of a transformer. The number of turns of the primary coil is represented by NP. The voltage or the potential with respect to the primary coil is taken as VP. And the current generated in the primary coil is taken as IP. Similarly, the number of turns of secondary coil is taken as, how we can take the number of turns of secondary coil? NS. Corresponding voltage or potential is taken as BS. And the current generated in the secondary coil is taken as IS. So here we are describing about the transformer. It is a device that is used to either increase or decrease the value of voltage. And it is basically consists of a soft iron laminated core and two coils. The coils are taken as primary coil and secondary coil. Primary coil means the coil at which the energy is given. That coil is known as primary coil. The coil from which the energy is taken out are called secondary coil. And some terms associated with the primary coil and secondary coil. The number of turns of the primary coil is taken by NP, and that of the voltage or the potential is taken as VP, and the current generated in the primary coil is IP. Similarly, number of turns of the secondary coil is NS. Potential or voltage of the secondary coil is taken as VS, and the current generated in the secondary coil is taken as IS. Is it clear? Now, depending upon whether the voltage is increased or decreased, depending upon whether the transformer is used to increase or decrease the voltage, we can classify the transformer into two. They are step-up transformer and step-down transformer. There are mainly two types of transformers are there. One is step-up transformer and step-down transformer. We have two different types of transformers. One is step-up transformer and the second one is step-down transformer. So we can discuss one by one. The first one is step up transformer. Step up transformer. Can you guess what is the use of this step up transformer? Is it is used to either increase or decrease the value of voltage?
Increase.
It is used to increase, as its name implies. Step up transformer is a transformer that is used to increase the value of voltage. Step up transformer is used to increase the value of voltage. In the case of a step up transformer, the number of turns of secondary coil, that is NS, is greater than number of turns of primary coil. NS is greater than NP. In a step up transformer, NS, number of turns of the secondary coil, is greater than number of turns of the primary coil. So here in this figure itself, you can see here the number of turns is larger or greater when we are compared to that of the number of turns of the primary. There are only 2 turns are there, but here you can see more number of turns in the secondary. So number of turns of secondary coil is greater than number of turns of primary coil in a step-up transformer. Step-up transformer, as its name implies, it's a transformer that is used to increase the value of voltage. Similarly, voltage or potential of the secondary coil, Vs, is greater than Vp. Instead of this Es and Ep, you can write Vs is greater than Vp. In a step-up transformer, Ns is greater than Mp. Similarly, the potential or voltage generated in the secondary coil is greater than that of the potential or voltage that is generated in the primary coil. Vs is greater than Vp. So that's all about the step-up transformer. Similarly, the value of current. But the value of current, Is, the current generated in a secondary coil, is less than that of the current generated in a primary coil. Is is less than Ip. Transformer is a device that is used to either increase or decrease the value of voltage. Depending upon whether it is increase or decrease the voltage, we have 2 types of transformer. One is step-up transformer and other is step-down transformer. Step-up transformer is a transformer, as its name implies. It is a device that is used to increase the value of voltage. In the case of step-up transformer, we have to notice 3 conditions. Here, Ns is greater than Np, Vs is greater than Vp, but Is is less than Ip. So that's all about step-up. Now we are going to discuss about step-down transformer. Step-down transformer. Here also, as its name implies, step-down transformer is a device that, it is a device that is used to decrease the value of voltage. Step down, it is used to decrease the value of voltage. And here, number of turns of the secondary coil is less than number of turns of the primary coil. Ns is less than Np. Similarly, Vs is less than Vp. Voltage or the potential of the secondary coil is less than that of the voltage or potential of the primary coil. But the value of current, Is, is greater than Ip. Exactly opposite to that of the step-up transformer. Step-down transformer is a device that is used to decrease the value of voltage. Here also we have to notice 3 conditions. That is, Ns is less than Np, Vs is less than Vp, and Is is greater than Ip.
Ma'am,
Yes, Sachut?
what is K is greater than 1?
It's a constant. We will discuss it later in our derivation. It's actually a proportionality constant. We don't need the value here. the value of K. Is it over? About the step up transformer and step down transformer? That's all about the step up and step down, as its name implies. Step up is used to increase the value of voltage. Step down is used to decrease the value of voltage. Okay. So now we are going to discuss what about the working principle behind the transformer as a whole. Not in the case of step up and step down. In general, what about the working principle of a transformer and how it is works, and how we can calculate the value of magnetic flux, number of turns, power generated by the transformer, and all. Okay. Now write the next heading, working of a transformer. Working of a transformer. It works based on the principle of mutual induction. The transformer works based on the principle of mutual induction. Transformer is a device that is used to either increase the value or decrease the value of voltage, and it works based on the principle of mutual induction. Then what do you mean by mutual induction? What do you mean by mutual induction?
Change in magnetic flux in one coil changes the EMF of the other coil.
Very good. So here also we have two coils. So if change in the magnetic flux associated with one coil is changes, if the magnetic flux associated with one coil is changes, what happens? It induces an EMF in the second coil. So here also we are using the principle of mutual induction. So the transformer is working based on the principle of mutual induction. So here they explain how the transformer works. So when a current in the primary coil is changes, here we are applying an alternating current to the primary coil. Then what happens? The magnetic field is changed. The magnetic field associated with the primary coil is changes. When a current is applied to this input end, magnetic field associated with the primary coil is changes. This change in the magnetic field associated with the secondary coil through this soft iron laminated core. Here both the primary and secondary coil is connected with the help of this soft iron laminated core. So whenever we are applying a current into the input end, the magnetic field associated with this primary coil is changes. This change in the magnetic flux causes a change in the secondary coil also, because they are connected or associated by a soft iron laminated core. Whenever the magnetic flux associated with the secondary coil is changes, it induces an EMF. Thereby, it generates an induced current. So this is how the transformer works. It works based on the principle of mutual induction. That is, whenever the magnetic flux associated with the primary coil changes, it induces an EMF in the secondary coil. So here both the primary coil and secondary coil is connected or associated with the help of a soft iron laminated core. Here we apply an alternating current to the primary coil. Magnetic field associated with the primary coil is changes. This secondary coil is placed in this change in magnetic field of the primary coil. They are associated with the help of a soft iron laminated core. As a result, the magnetic flux associated with the secondary coil is also undergoes changes. It will induce an EMF. That induced EMF produces a induced current in the secondary coil. Is it over?
Yes.
Okay. So now we are going to derive the expression for transformer. Okay. Write the next sentence. The magnetic flux associated with the primary coil is given by, or we can write the magnetic flux. The magnetic flux can be calculated by, magnetic flux can be calculated by, or magnetic flux is given by phi is equal to, what is the equation for magnetic flux? How we can calculate the magnetic flux? Equation, yes. Phi is equal to BA cos theta. Phi is equal to BA cos theta. For a maximum magnetic flux, maximum amount of magnetic flux, it becomes phi is equal to BA. What is the condition for maximum flux? Theta is equal to cos theta is equal to 0. So for maximum flux, cos theta is equal to 0. So we can write phi is equal to BA. For maximum amount of flux, phi is equal to BA. So this maximum amount of flux, phi is equal to BA, is only for one number of turns. Here we have n number of turns are there. For n number of turns, for n number of turns, magnetic flux phi is equal to, for n number of turns, magnetic flux phi is equal to NBA. For n number of turns, magnetic flux phi is equal to NBA. Okay. Then magnetic flux associated with primary coil is given by magnetic flux associated with primary coil is given by, primary coil is given by, so the general expression is phi is equal to NBA. This is the general expression for magnetic flux. Phi is equal to NBA. Here we are going to find out an expression for magnetic flux associated with the primary coil. So phi P is equal to number of turns of the primary coil, that is NP, into magnetic field and area of cross section. Here the magnetic field and area of cross section remains constant. So we can write phi P is equal to NP into BA. Magnetic flux associated with the primary coil is given by phi P is equal to NPBA. Similarly, the magnetic flux associated with secondary coil is given by, magnetic flux associated with secondary coil is given by, can you form an equation for secondary coil?
NSBA.
Yeah, phi S is equal to NSBA. Nothing, here we are just substituting the suffix P and S. Phi P is equal to NPBA and phi S is equal to NSBA. Magnetic flux associated with the primary coil is phi P is equal to NPBA, and magnetic flux associated with the secondary coil is given by phi S is equal to NSBA.
Ma'am, but there will be difference in area. The
In area, how? There is no difference in their area. Area remains the same. No change in their area. Area of the transformer in both sides, they are same. Only the number of turns of the coil varies. Here, the area of both sides are same. Okay. Now take the ratio between this phi P and phi S. Ratio between phi P and phi S. Phi P by phi S. Ratio between magnetic flux due to primary coil and the magnetic flux due to secondary coil is given by phi P by phi S is equal to NPBA divided by NSBA. Phi P by phi S is equal to NPBA divided by NSBA. Which terms cancels here?
Yeah.
BA and BA cancel. So we get phi P divided by phi S. That is the ratio between magnetic flux of primary coil to that of the magnetic flux of the secondary coil is equal to the ratio between number of turns of primary coil to that of the number of turns of secondary coil. So this is one of the important relation of transformer. Give this as our equation number A. Phi P by phi S is equal to NP by NS. They are directly proportional to each other. That is, if number of turns of the primary coil increases, magnetic flux associated with the primary coil is also increases. Similarly, if the number of turns of secondary coil increases, magnetic flux associated with the secondary coil is also automatically increases. They are directly proportional to each other. Phi P by phi S is equal to NP by NS. Now, by rearranging equation A, we get phi P is equal to, here I take this phi S into RHS. So phi P is equal to phi S into NP by NS. Phi P is equal to phi S into NP by NS. Take the derivative on both sides. By taking derivative on both sides, we get d by dt of phi P. That is, the rate of change of magnetic flux associated with the primary coil is equal to d by dt of phi S into NP by NS. The rate of change of magnetic flux associated with the primary coil is equal to the rate of change of magnetic flux associated with the secondary coil into NP by NS. So here we know that this NP by NS is constant. We can take it outside. So it becomes d by dt of magnetic flux associated with the primary coil is equal to NP by NS into d by dt of magnetic flux associated with the secondary coil. Then what do you mean by rate of change of magnetic flux? Rate of change of magnetic flux associated with the coil. There is a particular law. Specific law is the relation between rate of change of magnetic flux associated with the coil is given by if the rate of magnetic flux associated with a coil is changes, what is induced there?
Electromagnetic induction.
It is electromagnetic induction, something induced there. An EMF is induced or generated in that circuit. According to Faraday's law of electromagnetic induction, the rate of change of magnetic flux associated with a coil is equal to induced EMF. Similarly, here we have d by dt of 5p. So the rate of change of magnetic flux associated with the primary coil is given by d by dt of 5p. D by dt of 5p is nothing. It is the induced EMF of the primary coil. So instead of here E, we taken it as V. Instead of induced EMF epsilon, here we consider it as V. And according to Lenz's law, there is a negative sign is here. So d5p divided by dt is equal to negative Vp. Similarly, rate of change of magnetic flux associated with the secondary coil phi s is equal to rate of change of magnetic flux associated with the secondary coil is given by induced EMF in the secondary coil, negative Vs. Negative Vs. So here we are applying the Faraday's law of electromagnetic induction. So by Faraday's law of electromagnetic induction, the rate of change of magnetic flux will be equal to the induced EMF of that circuit. So here d5p divided by dt is equal to minus Vp. Similarly, the rate of change of magnetic flux associated with the secondary coil is given by induced EMF of the secondary coil, that is given by minus Vs. So we can substitute these values here. It will become d by dt of 5p means minus Vp is equal to Np by Ns into minus Vs. So this negative sign from both sides cancels. We get Vp is equal to Np by Ns into Vs. By rearranging, we get Vp by Vs is equal to Np by Ns. This is another important relation for transformer. The ratio between EMF induced in the primary coil to that of the secondary coil will be equal to number of turns of the primary coil to that of the number of turns of the secondary coil. Give this our equation number D. Vp by Vs is equal to Np by Ns. Here also they are directly proportional to each other. That is, whenever the number of turns of the primary coil increases, the voltage generated in the primary coil is also increases. Similarly, the number of turns of secondary coil increases, the voltage or EMF induced in the secondary coil is automatically increases. So by combining equation A and B, we can write here according to equation A, we know that phi p by phi s is equal to Np by Ns. Now by equation number B, this Np by Ns is equal to Vp by Vs. Therefore, by equation A and B, we have phi p by phi s is equal to Np by Ns is equal to Vp by Vs. This is our equation number 3. Okay. So here we derive the relation between magnetic flux, number of turns, and EMF induced in the primary coil to that of the secondary coil. Now the next heading, efficiency of transformer. Next subheading, efficiency of transformer. Efficiency of a transformer. Efficiency of a transformer is calculated by the ratio of output power to that of the input power. So this is the equation. This is a general equation. Efficiency. Efficiency is equal to output power divided by input power. Efficiency of a transformer is given by ratio of output power to that of input power. And this efficiency is denoted by a letter which is known as eta. Eta. Not theta, ETA, eta. Efficiency is denoted by eta. I think sometimes you maybe heard this term in chemistry. Have you heard this term? Eta. Efficiency is denoted by a letter eta. Students, what is the general expression for calculating the power? How we are calculating power?
V5.
P is equal to VI. Very good. But here we want to calculate the output power. Output power. From where we derive the output power? Is it from primary coil or from the secondary coil?
Secondary.
From where we derive the output power? Transformer mainly consists of two coils. One is primary coil and other is secondary coil. Primary coil is a coil to which the energy is given. And what about the use of secondary coil?
You know.
Secondary coil. Secondary coil is a coil from which we take the energy or the output is derived from the secondary coil. Okay. So here the general equation for calculating the power is P is equal to VI. Then the output power is given by, the output is derived from secondary coil. PS is equal to VSIS. Similarly, the input power is given by, is there any doubt? Input power is given to the primary coil. So PP is equal to VPIP. So the efficiency of a transformer can be calculated by the ratio of output power to that of input power. That is VSIS divided by VPIP. So if we know the value of secondary voltage and that of the current generated in the secondary coil, similarly the primary voltage and that of the current generated in the primary coil, then you can easily calculate the efficiency of a transformer. Efficiency of a transformer is given by eta is equal to output power divided by input power, or eta is equal to VSIS divided by VPIP. Again, for an ideal transformer, ideal transformer means it's a transformer in which the output power and input power are equal. So for an ideal transformer, this efficiency eta is equal to 1. Efficiency eta. For an ideal transformer, efficiency eta is equal to 1. Ideal transformer is a transformer whose output power is equal to that of input power. Input power and output power are equal. So efficiency eta is equal to 1. Or we can write VSIS is equal to VPIP. VSIS is equal to VPIP. Or by rearranging, we can write IS by IP is equal to VP by, take this VS to RHS, VP by VS. This is our equation number D. For an ideal transformer, the efficiency eta is equal to 1. That is, the electricity transformer with output power is equal to that of input power. So Vs Is is equal to Vp Ip. Or by rearranging the equation, we get Is by Ip is equal to Vp by Vs. So here in the equation number C, we get 5P by 5S is equal to NP by NS, which is equal to Vp by Vs. Again, from equation D, we get that Vp by Vs is equal to Is by Ip, not by Ip by Is. It is equal to Is by Ip. Okay. So combining equation C and D by equation C and D, we have 5P by 5S is equal to number of turns in the primary by number of turns in the secondary is equal to potential or voltage EMF in the primary by EMF in the secondary is equal to current in the secondary, not in the primary, Is by Ip. So this equation gives the relationship between magnetic flux, number of turns, EMF, and the current generated in a primary coil with that of a secondary coil. Now one more topic is left. Energy loss in transformers. Energy loss in transformers. Mainly in 3 or 4 forms, energy loss occurs in transformers. The transformer is a device that is used to either increase or decrease the value of voltage, or it is used for carrying the power over a long distances. So whenever we carry the current with the help of transformers, there is a chance of energy loss in the form of heat. So there are so many ways the energy loss will be takes place whenever we are using the transformer. One is flux leakage. One form of energy loss is flux leakage. And how this energy loss occurs due to flux leakage means there are some air gaps between the primary and secondary coil of a transformer. As a result, what happens? Because of which the change in flux associated with the primary is not completely transferred to that of the secondary coil. Due to the gap between primary coil and that of the secondary coil, the magnetic flux associated with the primary coil is not completely get transferred to that of the secondary coil. So here we can reduce this flux leakage by secondary coil is wound over the primary coil, that is in the case of toroid. In the case of toroid, the secondary coil is wound over the primary coil. So one method of energy loss that occurs in transformer is due to flux leakage. Try to write the names also, only the flux leakage. After that, we can explain it during the revision part. Another loss of energy loss occurs in the transformer is mainly due to resistance of windings. Resistance of windings. Resistance of windings. Next method, next energy loss in the form of eddy currents. Eddy currents. Eddy currents. And the last is due to hysteresis loss. Hysteresis loss. So the energy losses takes place in the transformers in the form of hysteresis loss, eddy currents, resistance of windings, and flux leakage. We will explain all these energy loss in detail in our next class or during the revision session. Okay, children, it's the time. Okay, children. With this, we can wind up today's session. Thank you all. Thank you.
Thank you, ma'am.